looks terrible. Alrighty. There are only two big ideas in calculus. One of them is figuring out the area underneath any curve. Do you remember what our first big idea was? Somebody said it over here. Slope, which is a derivative, slope of a tangent line. Why was that a problem to begin with? Because before this class, you needed what to compute slope? You needed 2 points, right? In a tangent line, you only have one. So the problem was, how do you figure that? And then there's all this other stuff. You know, I kind of lied to you because it ends up, okay, now how do you use that thing? And we went crazy afterwards, right? So now we're going to figure out the area underneath the curve, and we're going to start out by this method of estimation called Riemann sum. Now, I'm doing it differently than the book for those people that follow the book. I don't follow the book. What I do is I follow you. In other words, over a period of time, I realize, oh, I've done that kind of a poopy way. I got to do a better way. And so if you look at section 4.3, it's on Riemann sums. So I'm talking about it right away. So I do something a little bit different than I adjust the assignment, which is coming up. So a Riemann sum is an approximation of area by, you will see this word a lot, called partitioning. And part of math is vocabulary, and partitioning simply means you're breaking it into pieces. And sometimes when you break things into pieces, the pieces are equal, and sometimes they're not. So you got to be careful. And if they're equal, it makes life a lot easier. And every one of these problems is an AP problem. And if you're able to do these, you can get 3 points. Remember, out of 9, all you need is 5 to 6 points to get 5 out of 9. And it says, in the geometric shapes we use is a rectangle. So here's my first example. And I know you guys kind of did this for today, but I'm going to kind of make it more algebraic, more calculus orientated. And it says, find the area under this curve. So I'm going to draw this curve. And here's 0, here's 1, and I write 2. And here's 2, and here's 3. And if I put 0 in there, I get 1. Are you okay with that? And if I put 1 in there, I think I get 1.5. And if I put 2 in there, I think I get 3. And if I put 3 in there, I think I get 5.5. And so, I suppose that's for you. It means I got to get up. Oh, it stopped. They'll call back. Okay. All right, so there's my shape. And it says within the interval by using 3 right endpoint rectangles. And I ask you to draw this, and I ask you to do it on a quiz, and I ask you to do it on a test when I give you a graph like this. So I'm going to show you how to divide into 3 right rectangles. It means the right corner of the rectangle has to touch the curve. So I go as far to the right as I can, which is right here in this interval. And I need to make a rectangle, so I need to be parallel to the x-axis, and I keep going till I get to the first unit, which is 2, and I go straight down. Now I look at that. Did I do a good job? Is it a rectangle? Is this right corner on my curve? Yes. Yes. And then what I'm going to do is, if you notice, this comes here too, doesn't it? Right? And hits that curve. Well, then I'm going to hit the curve right here. And I have 1 point here, 2 points here, 3 points here. Would you agree? And I only need 3. Because it says 3. And so what I'm going to do is I'm going to complete my rectangles so they look like this. It's too much, isn't it? It's an over approximation. I can deal with an over approximation. I'm just following the directions. Now notice I did not include 0 here. You know why? 0 is way to the left, and I only went right once. So every time you do this, you're either going to exclude the 0 or you're going to exclude the 3. When do you think I exclude the 3? When I do left ones, because it would be shifted to the left. Does that make sense? All right. So, do all of these have the same width? 1, 1, 1. They do, don't they? In fact, the distance between 3 and 0 is 3 minus 0. And 3 is my number of rectangles, correct? And notice I get 1. So each of these rectangles will be multiplied by 1. Would you agree with that? So, in other words, I'm going to have 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3. Where did f of 1, f of 2, and f of 3 come from? Yeah, that's my height of my rectangle, isn't it? Because going up, why don't you just go? Because I can see you're nervous, aren't you? You can watch it, maybe. It's kind of a fuzzy video today. I don't know why. The camera is kind of tired. Okay? But it'd be nice if you come back. Right, y values are heights. Would you agree with that? Now, if I wanted to, I could factor out the 1. The 1 isn't doing anything, but I could say that's f of 1 plus f of 2 plus f of 3. Right? So really all I got to do is figure out what f of 1, f of 2, f of 3 is. Would you, everybody agree? So f of 1, if I put a 1 in there, what do I get? I put a 1 in here. What do I get? 1.5. You guys are like scaring me. If I put a 2 in there, what do I get? 2 squared, half of 2 squared, plus 1, 3. What else? That'd be the best answer. And if I put a 3 in there, what do I get? 3 squared, half of 3 squared, plus 1, 5.5. And I multiplied it by 1. I already did it. And so my area is got to be less than what? 10? Do you understand why I say less than? Yeah. Well, you got to take a look at your graph. Okay. Now, we're going to talk about how we know that ahead of time, because sometimes we won't be able to look at our graph. Okay. Let me just draw another graph, because since Allie brought it up. Let's say my graph went like this. And I did it right here. Is that an overestimate too? So what do these two graphs have in common? Well, it can't be concavity, can it? No, it's not concavity, is it? It's what? What does this graph have in common with this graph? Yeah. They're both increasing, right? They're going up and to the right. That's increasing, correct? How do you know when something's increasing? In calculus. You could do that. What's a really easier way to do it? Can I use the derivative? When the derivative is positive, correct? So on a right Riemann sum, when it's increasing, it's an overestimate. What do you suppose what happens on a right Riemann sum when it's decreasing? In other words, let's say I have this. It's going down, so this is concave down, correct? and this is concave up, but both of them are decreasing, and now I'm doing a right. What would you say about these? These are all right, correct? They're both decreasing. Is it an overestimate now? It's an under, isn't it? So this is what they're going to ask you. All you'll know is whether the function's increasing or decreasing. That's all it's going to tell you. And they'll tell you, what do you have, is your area an overestimate or an underestimate? You know what I do? I draw a little picture because I forget. I can draw those pictures. And then they go, oh, yeah, this is why. And your answer, because they'll ask you to justify, and you're going to either say because the function is increasing or the function is decreasing. That's all you got to say. It's hard to remember. All right, so here's this one. Now I have this same graph, but now I'm going to do left. And so I'm going to do left. And so here's 0, here's 1, here's 2, and here's 3. Now notice I'm only doing those 3 points, correct? I skip 3 because we're to the left. It shifts to the left, doesn't it? So what I do is I draw these lines down, and then I got to make rectangles out of them. An underestimate, would you agree? I could even shade to help you out. That's the best I can color. So again, I'm going to have 1, but this time it's going to be f of 0 plus f of 1 plus f of 2. Are we following this? Are you guys okay with that? Because this distance here is 1, this distance here is 1, this distance here is 1. And this length times this length, or excuse me, this length times this length is area. This length times this length is area. This length times this length is area. And that length, in this case is 1. And when I draw on this alley, I'm partitioning. When I walk a sidewalk, because the sidewalks in my hometown in Plainview are like sidewalks of the 1800s. They're like bizarre. And I'll walk with my wife because she likes going on walks. I'll say, look how these sidewalks are partitioned. I thought that would be a romantic comment. It's not. She just kind of rolls her eyes, looks away. All right, so f of 0. What is f of 0? 1. I think we figured this out to be 1.5. Am I right? I think we figured out f of 2 to be 3. Am I correct? So I get an area that is greater than 5.5, right? So in other words, I've created bounds for my areas with these using 3 rectangles. My true area is somewhere between 5.5 and 10. You will be asked to do that. They'll say, okay, between what 2 areas is the thing? Well, you do a left one and you do a right one. Okay, you have an overestimate, you have an underestimate. Are we okay with that? All right, page 2. Now what I like, here's another one, and this is midpoint, so it's the same graph. And here is 0, 3, 1, 2. Well, would you say there's a point in between 0 and 1 halfway? There is, isn't there? And if I go straight up, to that point, and then I make a rectangle through that point, I have some that's over and some that's under. Does everybody see that? And then right here is the midpoint, so I go up here, and I go a little bit over, a little bit under. And so these rectangles will still have a width of 1, but they're going to have a different height. Would you agree with that? And that height is going to be, in this case, dependent upon 0.5. In this case, it's going to be dependent on 1.5. And then this one is going to be dependent upon 2.5. And would you agree that's a better estimate? So it's going to be 1 times f of 0.5 plus f of 1.5 plus f of 2.5. But 1 is still their width. Well, if I put 0.5 in there, I get 0.25, correct? Which is a quarter. And I was taught in Kruger welding that half of a quarter inch is an eighth of an inch. And 1/8 plus 1 is 1 1/8, or 1.125. Are you okay with that? And if I put 1.5 in there and square it, and somebody probably should have a calculator just to make sure that I haven't gone over the deep end. I believe 1.5 squared is 2.25. And half of 2.25 is 1.125. So I believe you get 2.125, I think. Plus, if I put 2.5 in here, I get 6.25. Half of that is 3.125. Add a 1, I believe I get 4.125. So I'm thinking my answer is 1 plus 2 plus 4 is 7. 3.75, or 7 3/8. Is that correct? Aaron, did I make a mistake? You okay? Feeling okay? If you feel ill, if anybody ever feels ill, you know how I said you just get up and go to the bathroom, you don't have to tell me. If you feel ill, the same thing. If you don't think you're going to make it, rush into Karsh's room and vomit in there. It's my gift to him. Huh?
What do you do?
Yeah, just run in there. And then just leave. So my area is approximately that. Would you agree?
I don't know.
My area is approximately that. Do you agree? And it's some. Notice it falls within what we came up with before, which was 5.5 and 10, right? Am I any questions or okay? Okay, so this is the part that is kind of like English, because I think math and English are really similar, and I think I'm the only person that believes that, but here, people are wandering around here like, oh, is it? Uh-oh, he's looking to see if I'm working. And I just said that on the internet. I bet you I'll be fired.
It doesn't matter.
It doesn't matter. All right, so in English, we have words like this. To, and two. Ever notice that? Okay, like to, there, and there, right? Yup. Your and you are, no, your, yeah, your and your, right? Right. Well, we have the same thing. This is called a definite integral. This is called an indefinite integral. They look a lot alike. They both have an integral symbol. They both have 1/2 x squared plus 1. They both have dx. But they're asking two. They're looking for two different things. This one is asking you for the antiderivative and make sure you add c. That's what it's telling you. If you notice, it's up over there. Indefinite integral, and I got it up there. Capital F of x plus c. This, the definite integral, is asking you for the area underneath this curve between the x values 0 and 3. So this right here, this would be an approximation for the area under the curve. It comes from an indefinite integral. Yeah, this comes from a definite integral. I think I said indefinite. Indefinite means it gives you, you're going to come up with an equation that's the antiderivative. This, you're going to come up with a number that's an area. Does that make sense? Now, how can you tell the difference? Yes. This one has numbers here, correct? This one doesn't. So, do you guys know where vowels is? Yeah. Most everybody does. One time, this is not a true story, okay? But I use it, I always use it in my class. I don't know why I use it. I use it to try to help you remember. Let's say I'm at vowels, or you're at vowels, and you say, oh my gosh, I got to head west, down St. Germain, towards St. Cloud. You understand where I'm headed? Okay. And there's a blizzard going on. And the windshield wipers are going, and you can barely see, and you feel like that little old lady or that little man really scrunched up, and the defroster's trying to keep in here. You think you might kill somebody. I mean, you're going really slow, and you're kind of swerving, even though you're in four-wheel drive, you're really nervous. And then you see something move to your right. And you're going, oh my God, what was that? And you realize it's an integral symbol on the sidewalk. It's an integral symbol on the sidewalk. And it's traveling in this blizzard as you're driving. How do you know whether it's a definite or indefinite integral? It's easy. If it's a definite integral, it has a hat and boots. It has the numbers by the integral. The hat, the boots. I get stuff from people. And so this year, they gave me boots. And they gave me hats. Notice the hat, the boots, as it walks along the sidewalk during the snowstorm. So this right here, if you look, there's snow falling down in a forest, and there's a side mirror, you're driving. If you look in that forest, there's an integral, the definite Okay? That has nothing to do with the problem. Just thought I'd share that with you. All right, so what are we going to do? We need 6 right triangles, right rectangles, correct? I'm not drawing a picture. How wide will each of those rectangles be? How did you get a half? That's exactly correct. 6 divided by 3 is not a half, it's 2. Okay. In other words, did you take 3 minus 0 and divide it by 6 and get a half?
Yeah.
So is each of those rectangles a half? So I'm going to write 1/2 on the outside, and inside here are going to be the heights. Why can I do that? Because every rectangle is going to be, the width is going to be 1/2, correct? Now, they're right ones. So do I start with 0? No, because everything shifted to the right. I better end up at 3. Would everybody agree? So it's going to be f of what? 0.5 plus f of what? 1 plus f of what? 1.5. Are you simply adding 0.5 every single time? That's remarkable. Plus f of 2 plus f of 2.5 plus f of 3. Now I should count. How many of these f's should I have? 1, 2, 3, 4, 5, 6. If I would have started at 0, I would have had 7. It would have been wrong, correct? So I got 1/2. F of 0.5, I figured that out already. It's 1.125. I'm just looking at a previous problem. F of 1, I already figured out. That's 1.5. F of 1.5, I figured that out. It's in the problem above, 2.125. So don't think I'm a genius. I'm just copying stuff down. Plus, if I put 2 in there, I believe I get 3. If I put 2.5, I believe I got 4.125. And if I put 3 in there, I believe I got 5.5. Now I do need a calculator. What do you get when you add those up and divide by 2? Was that him who called? Okay. So what is my area approximately? You just missed my snowstorm story. You'll have to watch it on the video. You won't be able to see everything. It was quite exciting. They still don't get it. Do you? The hat and the boots? It's funnier now that I actually, somebody gave me a hat. 8.8? 8.8?
8.1, 8.2. Well, how far do you want to round? 3? Okay. 8.188.
Is that what other people got? Or did you get that? Or no?
I think I got 8.68, but I'm double checking.
Well, I'm checking. I'm going to use 1.5 plus 5.5 is 7. Is that correct? Plus 3 is 10. And 10, 11, 13, 17, and 3/8. Half of 17 is 8.5. Half of 3/8 is 3/16. So I get 8 point something.
8.6875?
I believe that's what I get. 8 point what?
688.
That?
Yep.
All right. It's a definite integral. What is it asking you to do? Find the area under the curve, correct? From what? Perfect. Using what? Okay, so how wide is each rectangle? Well, the distance is 2 minus 0, correct?
It's between 0 and 2, so it would be 1/2.
Right, it's going to be 1/2. Do you see how I did this?
Yeah.
Okay, there's a reason why I'm doing that, but does everybody see that each one's going to be 1/2? So my area is approximately 1/2 times. What am I going to plug in first? It says left 0, so I got f of 0 plus f of what? 0.5 plus f of 1. How do I know when to stop? When I hit 4 of them, correct? I'll have 4 heights. because I got 4 rectangles. So I get plus f of 1.5. Does that sound correct? Okay, so now I'm putting 0. That gives me my height, correct? 0 cubed is what? 0. That means I have a rectangle of no area. Right? You saw that yesterday, or you saw it for today? 0.5 cubed. 1 cubed I can do, that's 1. What's 1.5 cubed? 3.375, like that. So I'm going to add these together. I get 4.5. Does that look right? If I add those together? Am I right? Divided by 2, because there's a half. So my area is approximately 2.25. Yeah, it's a good question. Is it a less than approximation or a right approximation? Well, I'm not 100% sure. I'm kind of nervous. What does a cubic look like? It looks like this, correct? Right? From 0, and here's 2, and it'd go up to 8 over here, right? Right? You'd agree? And I'm using left. So this one would go to here, and then this one would go to here. Do I need to draw more of that, or do I realize it's going to be an underestimate? Do you see that? So A is going to be less than 2.25. Oh, excuse me. Yeah, sorry, greater than. Because I haven't, there's a whole bunch of area I'm missing. Right. The real area, this stands for the real area. Because 2.25 is too small. Are we all right with that? All right.